Okay. Um, I'm going to see alcohol as a big part in this image, very big part. So, you can see alcohol interact with aldehydes, ketones. And then our next chapter, alcohol interact with acids. So alcohols are a big deal in biochemistry. Now there's something called a carbonyl group, which is a carbon double bonded O. Now it's going to attach to a carbon, and that carbon can either have another, so it's going to attach to carbon, it can either have an H or another carbon here. If it's an H, it's an aldehyde. If it's something like a carbon, it'll be called a ketone. Okay. Now the way we draw it with a line drawing is going to be for a ketone, for an aldehyde. Now, naming aldehydes. Remember aldehyde. It starts with Al. That's going to be the functional group name for aldehydes. So like before, we choose the longest carbon chain that contains the functional group. Here. Okay, so let's name that. Carbon chain first that contains this. So it's always good to just start with the functional group. Then you know it's going to be included. Now here we can go left or right. Which way should we go? Right, because we go to the right, we get two carbons. We go to the left, we get one carbon. Okay, so my cough is getting better, believe it or not. So this is going to be a hexa now. Where the A denotes an aldehyde. And do we have branches? Yes, we have two methyl groups on carbons number. So it's going to be 3,4-dimethyl hexanal. Now, between the two, the aldehyde and ketone, ketones are more stable than the aldehyde. So in nature, you'll see many ketones, very few aldehydes. Now, these are some common aldehydes. So, particularly so there's formaldehyde with one carbon, acetaldehyde with two carbons, benzylaldehyde based on a benzene. The rest of them don't bother memorizing. They're not used that often. Okay, ketones. Naming a ketone, O-N-E. So, okay, so let's name that. All right, let's start with the backbone. Now my voice is cruddy because of this stupid whatever I have. Can you guys hear me okay in the back? Okay. Okay. Longest chain. We're looking at 1, 2. Does that have to? No. And we've got a branch. Okay, so we've got a branch for number 5. So it's going to be 5 heptanone. Okay, so naming is pretty consistent from unit to unit. You know, carbon backbone first. It's the functional group name. And then we do any branching. Yeah. Oh, I'm sorry. Yes, we do. Because that could be anywhere. Yes, you're absolutely right. Thank you for pointing that out. What was on carbon what? Carbon 3. Yeah, 3 heptanone. Now the aldehydes, do we have to number for the aldehyde? You have to number for ketones, you have to number for aldehyde. Okay, where are the aldehydes always looking? Again, so they're always carbon number 1. Now you can put in 1, blah, 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 leave it off. There's no other place for it. Or ketones can be anywhere in the mid section. That's why I don't like it. So I really get like it. Okay, so acetone is the most popular ketone by far. If you're in the building industry, MEK is frequently used as a solvent. Now, carbonyl group is going to have intermolecular forces of dipole, dipole only. For alcohols, there's an H attached to the O, so it has hydrogen bonding. So this is polar, but not as polar as an alcohol. Okay, we've got a alkane, there's always the lowest. Acids, well, we can study acids, but alcohols to this point will have highest. and everything else is in between. Aldehydes and ketones are similar, so they're going to be in between the two. So good old alkenes and alkanes are at the bottom. Ethers are a little more okay, because C double bond O has got a dipole in it. In polarity, it can bond pretty well with water. So frequently, aldehydes and ketones will be liquid, dissolved in water, particularly the aldehydes. And it's because of this, this here guy is partially negative. So it's attracted to the partially positive H water. Same with the ketone. And the little squiggly line in front of the plus and minus is a partial. If you take differential equations, you're going to get into partial derivatives. That's where that comes from. That's just a lovely class. It's interesting, but it's hard. Okay. Let me just talk. Okay. So in alcohols, as you know, because you're on your test Thursday, you probably know this really well, that a primary alcohol yield primary alcohol will yield an aldehyde in an oxidizing environment, which will then go on to become the acid. It's because there are two hydrogens next to that OH group, one hydrogen. Per hydrogen, you can do an oxidation phase. So a ketone only has one of those, so it can only be oxidized once. I bit my tongue badly, so I talk, feel I'm not enunciating very. Now, there is so much difference between the oxidation ability of aldehydes versus ketone that they're kind of isolated themselves into separate subfamilies. And a lot of a lot of tests you're going to be doing next week will take advantage of that for your first wet lab. Now, this is a good example of what you're going to do next week. You're going to be able to tell, you're going to get two solutions, and you're going to have an unknown. I'm going to ask you, the lab is going to ask you, which is a ketone, it's an aldehyde. Now, this is the oxidizing agent. It's potassium chloride. It could be any oxidizing agent, though. Frequently, this one's used because it's a pretty strong one. Okay, so when you dump this stuff, oh, and one other thing, if there's a reaction, there's going to be a color change. So then, so the oxidant is going to change colors if it's reduced. and oxidizes whatever. Okay, so when we dump those together, we notice there's no change here. Goes from orange to orange. That means no oxidation occurred. That means that was the test tube with the ketone in it. Ketones can't be oxidized. When we dump it in the other one, which is a aldehyde, benzaldehyde, its colors are changing. That means the oxidizer is reduced and oxidized the benzaldehyde to benzoic acid. So that's a really good test for aldehydes versus ketones. And you get to do it. Now, another test for aldehydes is something called a Tollens test. Now, you're going to need to know this reaction. We're going to use it in the carb section as well as this section. So, we have an aldehyde. We throw in Tollens reagent. The Tollens reagent is going to be Tollens reagent is going to be the oxidizer. Oxidizers have to be reduced if they're going to oxidize. So when Ag plus is reduced, it loses its positive charge to 0, meaning we have silver metal. And then the aldehyde gets oxidized to this. Now, in this test, I want you to just worry about Ag plus. Don't worry about exact formula. Okay, so we have an oxidation going on, a reduction going on. In redox reaction, that has to occur all the time, no exceptions. When an oxidation occurs, a reduction occurs. Because oxidation means it's giving away electrons. Reduction means you're gaining electrons. So you can't give away an electron without some place for it to go, basically. Okay, so know that reaction. Another reaction, it's called Benedict's reaction, and it's almost the same reaction, except we're not using silver, we're using copper. Same thing though. Aldehyde gets oxidized to the acid. The copper plus 2 gets oxidized to plus 1. Thank you. Okay, so these are two reactions you're going to be using. You're not going to be doing the Tollens in the lab. I don't know why not. Every school I worked at, we've always done the Tollens lab as well as maybe because it uses silver expensive iron. Anyway, Benedict's test is really cheap to do. Also, what's cool about Benedict's, and it happens like that. Seconds. For some of the reactions, you have to wait like minutes. This happens really cool. Okay. Now, Benedict solution. This is the one always quoted. It's kind of a rusty orange. But if you let it go, if everything is really concentrated, you get this greenish color. It's the same chemical, it's just it's complicated. It's the way the everything is attached inside the molecule. There's a little difference, but the colors a lot. Both of them are a positive test. And again, know this reaction as well. It's almost exactly like the other one, except it uses copper rather than silver. Now, to make an aldehyde, we oxidize a primary alcohol. If we want to make a primary alcohol, we then reduce an aldehyde. Remember, reduction is the opposite of oxidation. So we use a catalyst, in this case platinum, and then we are adding some hydrogen in. We end up with a primary alcohol. A ketone, when reduced, produces a secondary alcohol. So we end up, that's another way to distinguish between ketones and aldehydes. What kind of alcohol you make? A primary, secondary alcohol. So for example, here we've got propanol, 3-carbon aldehyde, catalyst, plus hydrogen gas, produce propanol, a 3-carbon primary. Here we have a 3-carbon ketone. So this is a 3-carbon. Okay, same conditions. Catalyst, we end up with 2-propanol, which is secondary alcohol. Okay. Now there are 2 layers of reactions in this chapter on aldehydes, ketones. This is the first layer, and I think it's pretty straightforward. Second layer is not. The second layer is the chemistry of carbohydrates. These guys here. Okay. So let's just for a minute here. Okay, so we want to make that. Okay. How do we make that? This is a good test question for Thursday. How would you make that aldehyde? There's the aldehyde. How do we make it? By oxidizing a primary alcohol. We go from here, here. Oops. And then because it's primary, we go this way, get the aldehyde. Where did we go? Let's just do it right here. Okay. Okay, so we have an aldehyde, and it's a 1, 2, 3, 4. So it's a butane now. So its carbon backbone is this. Carbon's long. So we make an aldehyde from a primary alcohol, 4 carbons long. So this would be butyl. In an oxygen environment. And that would be something you're going to run into Thursday. Look at this reaction. Oh, this is a ketone, 4-carbon ketone, so it's going to be butanone, and you don't have to label the aldehydes or ketones. You just put aldehyde or ketone. Since officially Unit 2 hasn't started yet for your test. Okay, what happens when a ketone is oxidized? Well, aldehydes oxidize easily, right? Do ketones? No, there'll be no reaction. All right, now let's erase this and start from scratch. Now, this is the first set of reactions we're going to have secondary backbones. Up to this point, we've only had primary backbones. Now we're going to have primary and secondary backbones. So you're going to have a different colored highlighter. So whenever we have so whenever we have a aldehyde and an alcohol together, they're going to react. What happens is this carbon here carbon that the aldehyde comes off of is a very special carbon. It's called a anomeric carbon. We're going to see these with sugars also. We're going to see it also with ketones. Anomeric carbon, that's where the carbonyl group, C double bonded O, attaches that carbon. And because that's the most reactable part of the molecule, is that carbon. The other carbons are very, very stable. Not that one, though. Okay. So whenever this happens, we end up going from an aldehyde to something called a hemiacetal. Think of the word hemi as partial. Okay, so the first step is this guy here. So we have the first attachment. Now, remember I said we have to have two backbones. The alcohol, the alcohol backbone is the secondary backbone. So when these merge together, here's the secondary one here, coming from the alcohol, attaches to the anomeric carbon once again. Then it'll further react with alcohol present as long as there's So sorry. If there's acid present, then alcohol will continue to react against the anomeric carbon. Okay, so we have a secondary backbone on the second alcohol. And normally, normally the alcohols are the same, except in carbs, not the same. So the second step is different alcohol. A lot of the stuff we're going to see again and again when we look at carbs. Like carb molecules tend to be more complicated. Okay, so we have the same acid, excuse me, we have the same alcohol added again, and this is going to be the that's going to be the secondary backbone, and that's going to attach here. And that's called an acetal. These are big deals. Chemistry. In fact, our Harmon Sherman did his graduate work in this. Okay. So we're going to have two kinds of molecules formed. We start with an aldehyde, it's going to be an acetal. We start with a ketone, it's going to be called a ketal to distinguish what was the original molecule. Now, the anomeric carbon is retained. That's still same carbon from which everything happened. Okay, so what we generated here is a COC COCO complex. So to identify an acetal ketal, you look for that OCO connection. If that's there, you have something that's an acetal or ketal. Okay. So that's what this stuff is down here. And this would be the flow chart for unit 2. Okay, so if we start with an aldehyde or ketone, we're going to get its hemi, since we already talked about aldehydes, let's talk about acetals. So we're starting with an aldehyde, we're going to end up with in the presence of an alcohol, a hemi formation. So it'll be a hemiacetal. And if there's still alcohol around, then it'll continue to go all the way to the acetal. Okay, and this is if aldehyde. If it's a ketone, you end up with a ketone. Now these require lots of practice, these reactions. I have worksheets to help you out with these. Okay, so I'm going to talk about how to identify whether one it's an acetal or ketal, and whether it's a hemiacetal or hemiketal. So there are 3 states a molecule can be in. Nothing. It's not acetal or ketal, or it's a hemiacetal, or an acetal, or a hemiketal or ketal? Three questions you have to ask. So question number one is OCO. So let's draw a okay, so what is that? Is that a acetyl or ketal? That's question number one. OCO. Yes or no? Yes. OCO. Okay. So it's an acetal or a ketal. I don't know yet. Okay. And that middle C on the OCO is the anomeric carbon. So on the anomeric carbon, is there an H present? And remember, carbon has four bonds. We have carbon, 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 carbon O, carbon O. So is there room for an H on there? No. That means it's not a hemi, acetal, or ketal. Because a hemi needs an OH off that anomeric carbon. Okay, and is there, that's on the anomeric carbon, this one here. Okay, the next one has to do with, so it's not a, because it's an OH there, it is a hemi something. Okay, the next question is it a hemiketal or a hemiacetal? Okay, then we ask ourselves, I'm going to put it over here so it's consistent. Okay, so there's an OH present on anomeric carbon. It's a hemi or hemi keto. If an H is present, it's either a hemiacetal or just a plain old acetal. Okay, so let's go through here. We got an OCO. Is it H present? No. So then it's not a acetal. is OH present? OH present, OH right there, anomeric carbon. Okay, so what is this thing then? Well, because he answered yes on the OH group, it's a Hemi something, right? If the OH is present, it's got to be a Hemi something, Hemi acetal, Hemi ketal. Okay, so that determines Hemi, yes or no. Okay, look at the H. Is there an H there? No. So that means it's not an acetal. It's got to be a ketone. So that is a hemiketal. Now this takes a lot of practice looking at stuff. You may find a molecule that's got, oh, for example, let me show you. Okay, so that's glucose. Okay, is there an OCO present? Yes. Right there's OCO. And OCO, remember the C is the anomeric carbon. That's where the action is. Now, with glucose, we're going to find the OH can be up or down. If it's down, it's an alpha. If it's up, it's a beta. Okay, so OCO, yes. Okay. Is there an H present? And that means it's some kind of an acetal. And is there an OH present? So that is a hemiacetal. And I made up this little test a long time ago, like 20 years ago. If the book doesn't clarify it very well, might. Okay. Let's do another one. So OCO, okay, and that's the, remember the one in the middle, carbon in the middle is the anomeric carbon. Okay, H present, OH present. Okay, so it's not a hemi. Because the hemi's got to have an OH on that anomeric carbon. So it's either an acetal or a ketal. So which one is it? Hmm? Okay. Is there an H here? Yes. That makes it an acetal. Now with glucose, it was a little trickier because you have all these OHs all over the place. But it's the same breaking down process. OCO, H present, OH present. Okay. Okay, so okay, we have an aldehyde and an alcohol. It's going to react. So primary backbone, secondary backbone. So what's going to happen is this guy is going to go here. And then this becomes an OH. So OCO, OCO, so we know it's something. Okay. Is OH present? Yes. Is H present? Yes. So it's hemiacetal. Now this is a big deal in carbs because if you have a hemiacetal, it's a reducing sugar. If you don't have a hemiacetal, it's not a reducing sugar. And that's a big deal in carbohydrate chemistry. Okay. However, with a little acid thrown in and the same alcohol or different one, you can do the same thing. We're going to have a carbon backbone. This is the original carbon backbone. This is the new backbone. We're going to have a new backbone right here. So this guy is going to attach here and replace the OH over here. So secondary backbones, primary backbones. And again, validate it's an acetyl. We go OCO is a yes. OH present? No. H present? Yes. So that makes that acetyl. We do the same thing with ketone. Same thing with a ketone. You should always identify anomeric carbon. Really helps. That's the whole center of the reaction. Okay. This just shows on the first go around. This guy just that replaces the fourth bond on the CO. So it reduces the double bond in CO to a single bond in CO with the attachment there. So our four carbon bonds can be maintained. And then with a little acid present, we do the same thing. Here. Now this hemi intermediate is not as stable as either the acetal or the original aldehyde or ketone. except in the case of carbs. Okay, well, let's look at a ketone example. So here is our anomeric carbon. And here we have primary backbone, secondary backbone. So that alcohol is going to attach to the anomeric carbon here. So here is our primary and secondary backbones. We add under acidic conditions. Now in our bodies, we do everything enzymatic. So we don't have to have necessarily acidic conditions because the enzyme takes care of that. Otherwise, this reaction would only go on in our stomachs. Okay. Okay, and then that attaches here and releases the OH. So we end up with two secondary backbones and primary backbone. And this is a ketone. Now, it's interesting. I ask a lot of chemists this question. Some books don't distinguish between an acetyl and ketone. Some do. And so I asked a lot of my friends that are teaching organic chemistry, and they go, it doesn't matter. Some people like it. I like the K's and the A's because the ketone, you know that it came from a ketone. If it just said acetyl on both of them, you wouldn't know what you started with. So in my class, I stay with the ketone and acetyl. Okay. So hemiketone, got to have an OH present for the hemi. Anomeric carbon is the middle of the OCO. And if we go further with another alcohol, we end up having a OCO again. No H. We don't have an OH or an H. It ends up being a full-blown ketone. H? No. OH? No. OH is okay, so that makes that a hemi. No general form. Now there's a lot to this unit. There are two major, we have kind of a OChem, and our next talk will be with a carbohydrate focus. But this is the chemistry of carbohydrates. Okay, let's look at this thing. Okay, we have an OCO, so we have something. So, main backbone, primary backbone. So, OCO, yes, H, no, OH, yes. So H no means it's definitely a ketal, hemi, or plain ketal. The OH present means it's a hemi ketal. This, yeah, OCO. So this is going to be atomeric carbon there. OH, no, means it can't be hemi. And H, no. So that makes that keton. Now, notice I didn't go into naming for these. Naming these isn't too bad, but you got to use this would be the main molecule here is propane, 3-carbon propane. And I don't, you don't have to write this down. I just want to show you the IU pack would name this. So it's based on propane. Carbon number 2, we've got an ethoxy. 2 carbons, ethoxy, and they're the same. So we have a 2,2-diethoxy propane. But I don't get into naming these in my class. They're not that hard, but it's good enough to memorize. Okay. Now this is tricky. If you have an alcohol and aldehyde on the same molecule, then they react. If the molecule is long enough, yes. So it has to be at least 5. In fact, let's just keep it at 6 to simplify things. 6 is long enough so that the tail can reach around to the front. Think of a dog chasing its tail. Like one of my dogs has no tail, so he doesn't chase his tail. My other ones are much smaller and they have longer tails, so they can find it. Okay, so here we have, this is the alcohol part. Okay, so let's look at this guy. We've got OCO, OH, yes, H, yes. Hence, this is a hemiacetal within the same molecule. Now, what does that look like to you, this molecule? Glucose, right. Glucose is an example of having alcohol and aldehyde on the same molecule. When the glucose is opened, I'm going to find cyclic sugars open and close. When they open up to an aldehyde. Closed, there's no aldehyde anymore. When they're open, they're susceptible to oxidation. When they're closed, they're not. Most of the time, in biology books, you'll see glucose closed. That's because it's more stable that way. But it opens up a fair amount. And then we throw in an acid, an alcohol, we can continue this reaction on to a full-blown acetal. Because here we have MEacetal plus an acid gives us an acetal. Okay. Now in a test tube, we throw a acid in to an acetal, it'll come apart. In our bodies, we have a physiological pH 7.04, so it's slightly alkaline. It's not acidic. So, doing the reverse set of reactions, here we have, let's do it down here. Primary backbone. Secondary backbone. Okay, so this breaks down to the original parts from which it was created. And so we have a 3-carbon backbone ketone, and the anomeric carbon is in the middle here. So that's going to be and that's where the ketone forms. And then you have the alcohols here, 2-carbon alcohol. There's 2 of those. If we had a aldehyde version of that, there. So what does that break down to? Some acid. Well, which is the original backbone? Here's the anomeric carbon here. So that means this was the original. So that's 3-carbon something. And we've got a 2-carbon. Oops. 2-carbon secondary backbone. So that gives us, what's the main back from which we started? Oh, it's 1, 2, 3. Oh, let's see, we have to analyze this. Oh. Okay, OCO, yes. H present, yes. OH, no. So that means we started with a what? This is the key here, the anomeric carbon.
Because there's an H on the anomeric carbon means we have started with aldehyde. So that's a 3-carbon. Three-carbon aldehyde. And the 2 secondaries are also 2-carbon. So we have propane and ethanol. Breaks down. Okay, I'm going to leave it here. As we've got test on Thursday, which you should be totally focusing on unit 1. And we have break. When we get back, we're going to pick this up again. So I'm going to review a fair amount in this first lecture when you get back and hit the acetals and ketal hard. Okay. So that's it for today. Remember, for those who came in a little late, the test is a take-home test. You download it, it'll be available on Thursday. You download it, do it, scan it, upload it. Okay? And I don't want you to play out in the formal way. Just put your ball on our way.
It's okay. There's like a chocolate covered strawberry crunch, but that one don't great. Not there's chocolate candies like put out the lab that is we're getting flat and we're getting a net chocolate and then a file here. I never went yeah, but we also have the cherry powder we're getting to like
Well, isn't this class different than Korean flying?
Like we just yeah. Is it one?
Yeah. Maryland, you always have an option. I'll be there.
Yeah. Yeah.
Spring week.
I would still. It's on here. Oh. Yeah. Have you started it? We need $1 million.
Oh, I'm listening.
So maybe we did that. Oh, yeah. It's a little thing.
Let me see if.
Yeah.
Yeah.
Yeah, and out here, look.
Okay, thank you.
There are so many things.
There's a couple there that I think. Well, that's one. It's thiol instead of hydroxide. No, it's the same pattern.
I think we're better shooting it today.
You can do that upstairs.
We are.
Does that mean you're not coming?
Yes.
And then this one I was kind of mind boggling. I've already done it.
You know, you can, this isn't true. So if you want to work on that some more, just, rescan it. And upload it again.
Right.
What it does, it replaces the file,
Whatever I previously uploaded, you
Yeah.
can file replace
as long as
it.
you don't change the name.
Okay.
So what did you think today?
Today was good, but today was kind of slow. You know, I'm full transparency, but I love you. But it was kind of slow. I just think that we need a little bit more, maybe some games to kind of grasp our attention out of our minds. Like a little game, maybe, on reactions and aldehydes and ketones. I don't know if you've ever done that. Like a bingo type of game or something where we learn the, a reaction game. Like this could be turned into a game or something, roll a little bit of dice and see what the ketones and.
I mean, if we had a giant dice. On all these little, parts,
Mhm.
we can say, okay, we're starting with an alkene,
Right?
and we go 2 places and it's, but it,
Yeah,
something like that.
yeah. If you go 2 places to the left or 2 places to the right or up or down.
Yeah. We're supposed to get 5 kids home.
I'm going up there this weekend. Good for me.
Yeah.
And you haven't actually graded anything yet, right?
But I think haven't I graded the, lab contract and the,
Yes, yes.
And the
Yeah.
okay, when I asked you that question,